Your answer is okay, Leo, except that you also can highlight if the environment that the robot is moving on is featureless, means that it's very hard to find a remarkable feature that he's able to really recognize as a mark in the environment, or if the environment is really changing so fast, certain condition, maybe at fire or something like that, then the map that he's trying to build for the environment it become useless when the environment itself is changing very fast. He cannot really find, he cannot make the loop closures. So a loop closure, you already know, it help him fix and fix the errors in his positioning, and he position inside the map. So without having a good features, or even without having an environment that is fixed, and or if it is changing so fast, then he is lost. Okay, and I would say, yeah, I think, yeah, that should be enough. Do you still remember the IMU?
Yes.
Some of the sensors in the IMU actually it's already found in the mobile phones. Wow. Okay, that's interesting. So I would say 3 sensors. I am not sure from where you get this 9. 3 and 3 and 3.
Like 3 second IMU has like, yeah, maybe I got a bit confused.
No, it's only
Just
3. Yeah. It's only 3. So mostly it is 2, and sometimes they have these magnetometers. So most of the time it is accelerometer and gyroscope, and sometimes they have magnetometer, but not all the time. Okay, but so your answer is okay. So what else?
That's all of paper 3. That's paper 1. If it's an autonomous agent, can I just say a feature, the autonomy, and then describe it?
So actually, this is a paper 1 question, but okay, it's fine. It's I somehow related to paper 3, but but it's
No,
paper 1.
that's because it's all of the, we've already like done all of the paper 3 questions here. That's why the next one is a paper 1 question. That's
No, no worries. It's okay. Actually, I select the one that there is a lot of paper 1 questions, but it's almost repeated. So I try to select the one that I think you might not be so strong in it. But I see that you are actually quite, now you are more stronger in paper 1 than paper 2 and paper 3. I believe if I want to level you are stronger in paper 1, comes after that paper 3, and then Um, paper two, I still think that you still need to focus a little bit more because the question sometimes is challenging. So that's my observation from your answers. Yeah, that's correct. So it take a decision without a human. The software keep running continuously. It sense the environment in real time. So okay, good. So let me summarize this. In short, loop through the array, compare each pair of consecutive elements if they are in the wrong order. Swap them, repeat until no swaps. This is in short, but your answer is okay. It's a detailed answer. Okay.
I'm not sure about this one actually.
Anytime you talk about binary, there is two important things: sorting and searching. So when they sort, especially if they are talking about the in order traversal, so it's actually fast to output this address book in alphabetical order. So here we are able to sort very fast. And also, if we want to do search, every time you do an iteration and comparison, you actually cut, you almost reduce the size of or the amount of times that you do this iteration by almost half. Okay, so do you remember how we do the binary search?
Yes.
So the binary search, every time you do an iteration, you have a start point and middle point and end point. A single comparison or iteration, it means that you already decide which half you want to search in. So it means that you cut the amount of searches by half. So that is totally different from the linear search. You understand linear search, right?
Yes.
Okay. So that is why the binary search or binary tree in general, it's very fast in sorting and also very fast to search items in it. Be aware that some of the questions that comes also in the exam, they will tell you if you are given an array and then you want to convert that array to a binary tree. So what are you going to do? They will not tell you to write a code here. They will ask you for description. Describe how can you convert an array or a 2D array to a binary tree. So that you need to consider. This is a kind of questions that can also come. So the concept that you are writing, the concept is perfect, but of course, um, since they need to use the standard operations here, first I would say that you have to call, you have to give names to the stack, as for example as s or st, and then you have to do the operations with a dot. So this is an example. And for the queue, if you say you want to say the in queue like that, so you have to use the name that he already give to you. Okay, not with, like that. So is the name of the queue dot and then the method, and then the operation, and then I would say use while, because we use that also a lot, and while, and then so we can use s is empty because this is one of the standard. Okay, and also you can use while q is empty. So of course you cannot use is empty, you have to use not is empty. I'm just giving you an example here, that you should use a standard. This is a standard method. Okay, so and other than that the concept is actually correct. This concept is actually correct, so it means that you just need a small touch here and there, and then other than that you are perfect. Yeah, and don't forget the not, and also goes here same. So my question now to you, uh, let me just confirm. You have a solid understanding, but I think maybe you just confused now. So first we have a queue that is full, and then but the stack is empty, and we are pushing what we are getting. We are pushing to the stack what we are getting out from the queue. So we will only stop if the queue become empty. But you are checking your condition here is related to the stack, not to the queue. Suppose S refer to the stack, and Q is referring to the queue, right? So your
Yep.
condition, am I right? Is it confusing?
No.
Initially, you start with an empty stack, so there is no meaning at all. You have to reverse. You you have to reverse. The condition is reversed. Yes, yes. Okay, fine. So there is a question that is related to the document that I passed to you, which is the name is, let me see here, this data structure exam question that I passed to you. Just open the A part of the question, and then uh, just tell me first how it looks like in your eye. Is it difficult? Is it easy? Well,
I think
well,
it's doable.
it's doable. You sure?
Yes.
Okay, okay. So, but you have to understand that this is only part of the question that I copied. Um, the 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 complete question is actually in the other PDF file because it's a long one. So, in short, he is talking about a 2D array which represent an image that have ones and zeros. They just want to um, invert the ones to become zeros and the zeros to become ones. It's doable, right?
Yes.
Okay, okay, good. Um, so before we leave, I would like to share something with you actually. And it's interesting because when I give it another thought, I think that they make a mistake in even the answers that they're providing. So you remember when we talked yesterday about this for loop for the swimmers and the race? Let me share with you, please. So you off your share. So I think now you can see this is an official answer for the question. Um, you make the for loop yesterday, and this is you have done it in Java. Uh, your problem here that of course you will lose a mark because you didn't initialize this temp swim array properly. You already created the first portion, but you didn't use new. So definitely they will, if you didn't create them properly, then you will lose mark here. The for loop is okay. The key problem is actually here. Okay, so we said that we have race 1 and race 0. Every race class, this is a class, right? So every race can carry up to 8 swimmers inside it. So every race class have an array of swimmers, up to 8. If you see in the exam question, both of them have null. So it means that they are not full with 8 swimmers. So do you still recall?
Yeah.
Okay. Now look at this. This is actually quite wrong. So the correct one. So this portion we talked about it yesterday, and it's fine, except that if we have an array, so we should write temporary swim like that, which is the name, and then we give it the new index like that, and it should equal races I dot swimmer, and the same goes here. There is no worries, but you should not add dot swimmer because temporary swim is just a list of swimmers. Okay, and inside swimmers there is no another swimmer inside. Can you check, please? Are you able to open the
Uh,
PDF file?
Yeah.
So do you see the UML that is in page 1 for the swimmer class? Does it have
Yes.
anything called swimmer inside?
Just a second. The swimmer?
Yes, the
No.
swimmer class. It doesn't have, it have name, it have school, it have event ID, it
Event
have
ID
time.
and time. Yeah, but that's
So
all. Yeah.
yes, so you cannot, if it is a list or an array of swimmers, there is no way that you can use dot swimmer. So this is totally wrong. And the same goes with the time. So the same goes with the time, especially that this temp time is actually a double, and a double does not have anything inside it. You just put number inside that, so you cannot put dot time also. This is totally wrong. So you have to say temp time index, and then you say races I dot time here, and you put the J, and that's it. So this is the only thing that I have a comment as here. So this is just a normal array, and you don't need to put dots here. This is totally wrong. It doesn't make any sense. And other than that, it's fine. Is it clearer to you?
Yep.
Okay, good. Then I would say, am I able to give you a little bit extra exercises, exam questions to solve? No, I mean not now. I mean as a homework,
Yep.
or you are having exams.
No, it's fine.
Okay, then see you next class then. Take care.
Yep. Thank you.
Okay, bye bye.